everyone. This is 10.1 warm-up proof number 2. The PDF of this can be found in the Google Drive, and I always encourage you to try it on your own first. But then if you want to check your answers or just are stuck and want to see how it works, then this is great for that. So this proof is it's trying to prove the theorem that's in our textbook about the external tangents being congruent, which is kg in this case and jk. So we're trying to prove that kj is congruent to gk. Those are called external tangents. They're called tangents because they touch the circle in only one point. So those are considered tangent lines. Tangent lines we know from your reading or from another theorem. Tangent lines are, it's kind of definition really. Tangent lines are always perpendicular to the radius. So you can see how this 90-degree angle is already there for us. But that just comes from the fact that these are tangents. So they're kind of given to us as tangents. Let me do the proof. Statement. Reason. Okay. What do we know? Well, we know we have tangent lines. I'm not going to write that down, but we really should know that. So, maybe I will. Let's write it down. KG and JK are tangents. So that's given. And that fact tells us that angle HGK and angle HJK are right angles. All right, that's it's another theorem kind of, but let's just say because they're tangents, right? Tangents are perpendicular to the radius or radii. Okay, so that gives me a good place to start. We can use this fact that the radius of a circle is the same no matter where it's at. That's very, very useful, and it comes up a lot when we're dealing with circles. So always look for that. This is a case where we are going to use it. So we know HG and HJ are the same. Because they're the radii of a circle. Can use shorthand notation for a circle. And I also know that this HK is congruent to itself. And if you haven't figured it out yet, I'm trying to use congruent triangles to do this. But hopefully you see that coming already. This is the reflexive property when something's congruent to itself. And hopefully you can see that I have congruent triangles already. So I'm just going to go right into it. HJK is congruent to, just try to get the letters correct, HGK. And this, it kind of looks like a side angle side thing, but it's not, right? Because the right angle is not between the two side lengths. But it is a right triangle, so I can use the hypotenuse leg. Some of you might be thinking, wasn't that angle side side, which is not one of the good reasons, but it is hypotenuse leg, so that works. So we've proven they're congruent. If they're congruent, that means all their parts have to be congruent. So I can go right into what we were trying to prove. JK is congruent to GK. That is, corresponding parts of congruent figures are congruent. And there you have it. We've proven that this external side and this external side, those tangent lengths, have to be the same. So that's one of your theorems in the book, and we're going to use that to solve. If you knew that this was 20 centimeters, you can immediately say that this other side is 20 centimeters, as long as you know that they're both tangent to the circle and of course they intersect in the same spot.